All right, let's take a look at number 20. So the function r of x represents the radius of a circle for a given area x. So that means the input is the area and the output is the radius of that circle. So this is the graph right here. Now, according to the graph, what is the approximate average rate of change in the radius of the circle as the area increases from 3 square feet to 7 square feet? Okay, this is your favorite thing. Rate of change, remember, is your slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Anytime you see this rate of change, we're calculating the slope between 2 points. Now, this is a curved line, which means that when we create the slope, we're going to create a straight line. So from 3 feet to 7 feet, we're looking at an output of 1 to 1.5. So I'm going to use that to create my slope. So my y value for my later value, y sub 2, is 1.5. My y value for my earlier value is 1. And then I'm doing that over 7, which is my input for x sub 2, and minus 3, my input for my x value for my first value. So I'm going to get 0.5 over 4. So 0.5 divided by 4, if you don't recognize what that is instantly, is going to be 0.125. And so that is your answer for this one. Okay, so remember, if you see that rate of change, you're using your slope formula where you're subtracting later value minus earlier value all over the later input over minus the earlier input, okay? Or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, let's take a look at the next one. This is which graph represents the equation 5y minus 3x equals negative 15. My first thing is always going to be put this in slope-intercept form. So when we do that, remember, we're solving for y. So I'm going to add 3x to both sides, and we'll get 5y equals 3x minus 15. Divide both sides by 5, and remember, you have to divide everything by 5. So we get y equals 3/5 x minus 3. So let me write that. Y equals 3/5 x minus 3. 1, this tells us that we have a positive slope. So that helps me to eliminate C and D, which both have negative slopes because they are going down. The next thing it tells me is that the y-intercept is negative 3. I can then eliminate graph A because the only one with a y-intercept of negative 3 is B. We can also just verify that I'm going up 1, 2, 3 and over 1, 2, 3, 4, 5. So I do in fact have a slope of 3 rise over run 5. All right, 22. Okay, 22 has a cylinder on it. And so you're going to go, wow, what is that? Now it's asking you, what is the function of the volume V that is inside the larger cylinder but outside the one with the smaller radius? So we're calculating the volume that's in the space around the smaller cylinder, right? Which means we're going to subtract the volume of the smaller cylinder from the volume of the bigger cylinder. In order to do that, you need to know how to find volume. Now remember, on CAPE, you will have this reference sheet, and so you're going to look for your cylinder, which is right here, right? Oh, I highlighted a whole bunch of things, right? Your cylinder formula right here, which is pi r squared times the height. Pi r squared gives you the area of a circle, so pi r squared times the height is going to give you the volume of a cylinder. So let's go back and look at this. So volume equals pi r squared times the height. Okay, so the volume of the larger cylinder is that we have a radius of 10 here. So that's going to be r squared, sorry, pi 10 squared times the height times 12. That's the radius of the outer circle. The radius of the inner circle, the inner cylinder rather, is the same height, so it's also going to be 12 times 12, but we don't know what the radius is, right? So that will be minus pi r squared, because we don't know what it is, times 12. So we have to first square. So this is going to be 10 squared is 100 times 12 minus pi r squared times 12. Okay, we can rewrite that part as 12 pi r squared. It just looks a little bit nicer. Okay, now here then I can multiply 100 times 12. Hopefully you recognize that that is 1200, but let's, just in case you get 1200 or 1200. Okay, so 1200 pi minus 12 pi r squared will give us the volume that is in the space between those cylinders. And so that leaves us with A. Okay, now someone that chose B would have not squared the 10, right? Someone that chose C is only finding the volume of the inside circle or inside cylinder. And someone that is finding D is finding, has factored out the 12 pi, but has erroneously squared both the 10 and the minus r there, which we don't need to do. So we're looking for the volume of the larger cylinder minus the volume of the smaller cylinder. Part B says, suppose that there's space between the inner and outer cylinders, right, which that's what we're looking for, right, the space between those two. And the radius of the inner cylinder must be an integer greater than or equal to 3. What is the domain of V? So what does the radius have to be? Well, the radius of the outer circle is 10, and it says, suppose there's space between the inner and outer cylinders. That means that it can't be more than 10. It has to be less than 10. And it says that it's an integer, right? The radius of the inner circle is an integer, meaning it's a whole number, okay? So it can't be all integers because it can't be, that radius of the inner circle can't be more than 10, right? It also can't be 10 because if it was 10, then there would be no space between the two circles. So that means that it has to be C or D. Well, C would include half numbers. It would include decimals between 3 and 9. And this says integer. So the best possible answer is C. The best possible radius would be 3, 4, 5, 6, 7, 8, or 9 because it's less than 10 and they are integers or whole numbers ranging from 3 to 9. All right, let's take a look at number 23. So a certain type of lily plant is growing in a pond in such a way that the number of plants is growing exponentially. So already know we have an exponential function. Okay, something to the power. The number of plants n in the pond at the time t is modeled by the function n of t equals ab to the power of t, where a and b are constants and t is measured in months. The table shows two values of the function. So this is giving us the starting value and then the second value, right? It says which equation can be used to find the number of plants in the pond at time A. Well, we know our starting value is 150, right? So it has to be A or C. The next thing we want to figure out is what is our factor? Are we multiplying by 1 every time, or are we multiplying by something more than that? Well, we go from 150 to 450, right? And so 450 divided by 150 gives us 3. Remember to find the factor in a table when we have numbers one right after the other or consecutive inputs. We can do 450, the later value, divided by the earlier value, which gives us 3. Now we have the factor. So here our equation is best represented by C, 150 times 3 to the power of t, where 150 is our starting amount, and then it's increasing times 3 every, I believe this represents months, so every month. All right, you know what? We have time for one more. 24. The ordered pairs are points on the graph of a linear equation. Which of the following graphs shows all of the ordered pairs in the solution set of this linear equation? Okay, so the first thing that we're going to need to do here is consider what is our slope, right? So if we have 2 points, we can find out what our slope is by using, again, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm choosing these 2 points, and you could choose any 2 points. I'm choosing these 2 because these both have 0.5s in them, so I'll get a nice whole number from them, okay? So I'm going to designate this as x sub 1, y sub 1, and this is x sub 2, y sub 2. So I'm going to do negative 32.5 minus negative 29.5 all over 22 minus 20. Well, a minus is going to become a plus here, but this is still going to be negative because negative 32.5 plus 29.5 is still going to give us a negative answer because negative 32 is larger. So negative 3 over 22 minus 20 is 2. This means that I have to have a negative slope. So it can either be A or D. Can't be B or C, right? Now let's look at these slopes here. So if I look at this slope here, let's choose 2 points. We're going down 1, 2, 3, and over 2. That looks pretty good. Let's look at this one here. Let's pick a point here, and pick a point here. Here I'm going down 2 and over 1, 2, 3, 4. So this would be a slope of negative 2 over 4, negative 1/2. And so A is our best answer. Okay, that's all you really needed to do for that, is figure out what was the slope, because these all have different slopes. And once we realize it's a negative slope, then that helps us to eliminate some answer options.